Thank Luis Hernandez, Soil Survey Regional Director for Region 12, for being here to support our webinar and introduce our presenters. Luis, I'm going to turn the webinar over to you so you can introduce the topic and our presenters.
Okay, yeah, thank you, Sean, and hopefully everybody can hear me okay. So this is Luis Hernandez. I am the Soil Survey Regional Director for Region 12. So I'm going to make some opening remarks for this presentation, and then we're going to have Donald Parisek, who is the MRA Soil Survey office leaders out of the office in Torrance, Connecticut. And then after Donald, we're going to have David Surabian, who is the state soil scientist in Connecticut. So the objective of this webinar is just to share information with you guys about the Northeast Coastal Zone Soil Survey Initiative. That is an initiative that is in the make, and we are getting ready to start the work. What is a coastal zone soil survey? Some of you may be asking, what is the difference between the conventional soil survey and the coastal zone soil survey? And in a nutshell, no big difference. We're gonna, the only difference is that on the coastal zone soil survey, we just focus on the coastal zone. The techniques for mapping, classification to develop interpretations are very similar to what normally we do during conventional soil survey. Some of you may be asking, why, we're doing this coastal zone soil survey initiative, and who came with the idea? So let me share with you that this initiative was a request that came from 7 state consolidations from the Northeast region. They asked the Soil Science Division to pay more attention to the coastal zone. So what we're going to do, this work in a partnership effort under the umbrella of the National Cooperative Soil Survey. So that's the plan. Excuse me. What we plan to do is to generate information, soil information, so the agency as well as other folks out there can use this information, like for example, the agency for implementation of NRCS programs, and to manage, some of the environmental challenges that we're having and that we may have as, these climate change things keep moving forward. Next slide, please.
Okay.
Okay. So I guess that this slide shows a map. This is the project area. This is a rough map that we are going to refine as we move forward with this work. So as you can see, it's a huge area that goes all the way from the state of Maine south to and touches the state of Maryland. So this work is going to touch 2 regions. Soil Survey Region 3, that is the region out of Raleigh, North Carolina. We are working closely with Debbie Anderson and the regional office staff in Raleigh, and then the folks in Region 3. This work is going to be conducted by 3 MRA Soil Survey offices, and you can see on the top of the slide there, Treeham, that's the Soil Survey office out of South Jersey, Hamilton, New Jersey, and that is within Region 3. And then we're going to have the office in Toland, 12 Toland, and the office in Dover in Maine. The office leader in Toland is Donald Parisek, who is going to be talking to us after me. And then the office leader in Dover is Nick Bucklow. This work is going to touch portion of 6 MRAs regions out there. I know that the map does not show the MRA regions, but we already know that this work is going to touch about that number of MRA regions out there. And this work is going to touch 9 states out there. And you can see on the map, get an idea of all the states that are going to be touched by this work. Some of you may be asking how long this work is going to take. And to be honest, Right now, we do not know. We are in the planning phase, but this is what I can share with you, folks. We're going to look at technology to see how technology can help us, not just to expedite the production, but also to improve the quality of the products that we're going to generate out of this work. Something like digital soil mapping, raster soil survey. I mean, we're going to look into those type of technology to see how it can help us to do to complete this work. In addition, and this is very important, this work is going to be completed in a partnership effort. If anyone out there thinks that this work is going to be completed just by NRCS alone, that is not the way we're going to do it. We're going to bring cooperators, we're going to bring our university partners, we're going to bring our federal partners, we're going to bring whoever is out there that want to get on the table with us under the umbrella of the National Cooperative Soil Survey to help us with this work. So this is going to be a partnership effort. And then last but not least, again, as you can imagine, it's a huge area, a lot of priorities out there. So my recommendation to the group that is going to be establishing priority for this work is to look and try to go for the low uppers. We have folks out there like Robbie Tunstead out of the office in Hamilton, New Jersey. We have David Sorabian in Connecticut. We have Jim Turin in Rhode Island. I mean, we have many folks out there already that are conducting this work on the coastal zone, specifically on the aqueous mapping. So I think that we're going to work together, again, a partnership effort, and we're going to try to go for the low uppers, try to finish the work that is already in the make. And there may be other work out there that needs some quick tweaking, and then we're going to focus on that too, so we can generate some product to share, with folks in the agency, our cooperators. So that is what I got from me. So I guess I'm going to just introduce Donald. Donald, so I'm going to give you the floor, please.
Thank you very much, Luis. My name is Donald Perzak. I'm the MLRA Soil Survey Office Leader here in the Tolland office in Connecticut. So I'm going to pick up the presentation just to make a case for coastal zone soil survey. Sea level has been rising for thousands of years, ever since deglaciation, and we have evidence that it's risen between 0.4 and 0.1 inches per year in the last 100 years. That's going to continue on, and there are many predictions that state that it will continue on at a much more rapid pace. So I think coastal zone soil survey will play a vital role in predicting what things will look like in the future, and you'll see more evidence for that later in the presentation. Aquaculture is a huge segment of the economics of the country. A lot of value, and as natural stocks of fish and shellfish dwindle, aquaculture is going to step up and fill that void. It can only grow, and it's growing quite rapidly here in the Northeast, and they're in need of subaqueous mapping for certain. And where do all the people live? Most of them live along the coast, along the coast of our nation. And those people, wherever you find a lot of people, you get a lot more interest and use of the soil survey. So I think there's going to be a much larger demand for soil survey, in the future along our coast as things begin to change as our climate changes, and we have people migrating more and more to the coasts. ecological site descriptions, a very important part of our workload here in the Soil Survey Office is developing ecological site descriptions, and we don't stop at the water's edge with those. A lot goes on, underneath the shallow water systems, and we need to be capturing our soils data for those areas. More on this topic, the definition of soil does include subaqueous soils. Soil science is a fundamental building block for all other resource management. I feel like I'm maybe preaching to the choir here because most soil scientists understand the importance of soils, but it plays into so many other facets of resource management. There's a huge undertaking to account for all the carbon. Carbon accounting is a big science these days, and especially blue carbon. Blue carbon is the carbon stored beneath the water. NRCS programs here in Connecticut, ever since Superstorm Sandy came through back in 2012, we've had these coastal floodplain easements, and over $5 million have been spent on approximately 90 parcels here in Connecticut. So they're buying up easements. It'd be nice for them to know exactly what soils they're buying, are included in these easements. We have an existing survey now, but it doesn't do justice to the coastal areas. Coastal wetland restoration efforts, it would be ideal to have current and updated soils information for these areas. It can't help but benefit that whole effort. Building new partnerships. Ever since we started working on coastal zone soil survey, we've been working with new groups, aquaculture groups, different types of restoration groups, universities, not our traditional customers in traditional agricultural areas. So it's been a real eye-opener as to what's going on out there, and enabling soil survey to move into the future. We're building a newer customer base, and we want to remain relevant for future generations. You don't want to have them say, that was a soil survey that was done the first 100 years. We want to maintain our relevance here well into the future, and I think coastal zone soil surveys, one of the ways that we can do that. There's a few examples of what's going on up here in the Northeast for people that might not be from this region. Superstorm Sandy came through, caused a lot of devastation along the coast. It'd be good to have updated and current soil survey information in these areas. Unfortunately, sometimes it takes a major disaster to bring in a lot of funding for research and mapping and things like that, but that seems to be the case of what's happened here. We have a huge aquaculture business here in Long Island Sound and throughout the Northeast, growing fish and shellfish. We also have a lot of ecological restorations that go on in salt marshes and adjacent coastal areas. And the more current and detailed the soils information that we have, the better these projects will go. And as you can see in that photo of the salt marsh, we have forested areas backing up right to salt marshes. What's going to happen in 100 years when sea level comes up a meter? And, what's the predicted outcomes there? And we can see evidence for that. I'll show you that later in the presentation here. So as a definition of soils are updated to include subaqueous soils, capable of supporting rooted vegetation. And as you can see on that profile picture on the left, all kinds of evidence of horizonation there. I can see very clearly, we have, some horizonation, which indicates, we have all the soil forming factors taking place. So that's pretty clear. So taxonomy has been constantly being updated to handle these new taxonomic classes. We have the WAS sense for the mineral soils that are, basically have a positive water potential, and then we have the WAS-cis for the organic ones that are subaqueous. And this is what we're trying to get after. This diagram here kind of sums it up, and we're trying to make sense and understand. We're building models to predict what we're seeing in the near shore coastal areas, both above the level of the water and below. As you can see in this diagram here, there's a barrier island, basically a barrier spit over here, and that tends to migrate. That's not a constant. And as it migrates inland with sea level rise, it tends to override the salt marshes. And we'll see that in our soil cores all the time. And you can see some of the subaqueous landforms that we have. We have this washover fan here. We have a flood tidal delta coming in through this inlet. And then the flood tidal delta slope here grading into this very low energy lagoon bottom. So we tend to accumulate our highly fluid, finer textured soils here, and our much coarser, sandier ones will tend to be in these high energy areas where current keeps the finer particles suspended. And then we go over here to the uplands, and we see, lo and behold, there's some submerged uplands in here, which were at one time well above sea level, but now have been, inundated over time. Remembering that sea level is rising, and it has risen for many, many years. You can go down and see some of this in this oblique aerial shot, a little Narragansett Bay, these washover fan areas, these inlet areas, and then the washover fan slopes over here, and this would be the lagoon bottom. So things really do, so we see that, and lo and behold, the soil cores that we see here, they're dramatically different for the different positions of the landscape, that we see underneath the water bodies. And this is what we're after as well. We're after posting the soil survey information, making it available on Web Soil Survey and other venues, so the users can get at it. As you can see, this is a shot from Rhode Island, showing not only terrestrial soils, but subaqueous soils, and all that information is available online. And that's our ultimate goal with this coastal zone project, is to be able to provide that seamless coverage from the terrestrial areas into the subaqueous areas. If you think about it, nitrogen, phosphorus, other contaminants and pollutants, they don't stop at the water's edge. Things continue on. There's a lot going on there, and to really make sense of the whole picture, I think it's very important that we map those shallow water subaqueous areas out. Subaqueous soil survey, in a nutshell, it's about strong partnerships. There's so much equipment and expertise involved that NRCS cannot go at it alone, and we've worked closely with universities, especially the University of Rhode Island, Professor Mark Stolt, and many of his grad students over the years. And I can't stress that enough, that you're not going to go out, and it's not like the old days where a soil scientist goes out with a map board and traverses across the landscape solo. This is a real team effort, and with a lot of strong partnerships involved. Subaqueous soils, some people don't really say, well, they all look the same. If you take a look at this picture, they're not all the same. They have properties very similar to terrestrial soils. You can see there's so much going on down there that we're unaware of. We're unaware of because we don't see it and we haven't sampled it. It's a fairly new field to be in, and it just has. You can see that things are different across the landscape, just as they are in the terrestrial world. And this slide will tell a lot. The pedon on the left there, that came from Rob Tunstead. That's from Barnegat Bay. That's a submerged aquad, a wet spodosol. And you can see right about 80 centimeters from 80 on up. Those are marine sediments. From 80 down below, that represents an old freshwater wetland that was inundated by sea level rise and time, preserved, in that profile. It tells one heck of a story of what went on in the past. The one in the center there, that came from Little Narragansett Bay. That was below about 2 meters of water. That's a submerged tidal marsh. And underneath that tidal marsh, we actually got into some old Atlantic white cedar swamp. So we had a stratigraphic record that went from a freshwater wetland to a salt marsh wetland, and then into a subaqueous soil above that. So it's a nice record. And the one on the right, that's a submerged headland soil. And you can see right at 2 feet, you see a much lighter colored zone. This is glacial till with a little bit of an aeolian cap on it. And this had a lot of fresh water seeping down through and exiting into the salt water. So this was an area where fresh water entered, lower temperatures, oxygenated water, and that's why we see those brighter colors up in that zone from like 2 to 3 feet in that profile. So you have these past environments available for viewing in the subaqueous cores. They provide us with current conditions, but they're also great models for predicting what's going to happen in the future as sea level rises, as it encroaches up into the headlands or over a salt marsh. What's going to happen, or down in the coastal plain, you're going to be flooding out a lot of your aquads with seawater. It's a key to what's going to happen in the future. So one of the first things that we need to do when we're doing a subaqueous soil survey is create a base map. And how we do that is we collect bathymetry. You can't see the landscape like you can off an aerial photo, or just walking the landscape. So we go out and we do some sonar work. using GPS, fathometer, acoustic depth sounding equipment, but we need to survey these things in to get a a reference point. So we use RTK GPS units for that. But we have, along the coast, we have this issue with the tides. We have a lunar tide cycle that varies from different times of the month. A daily tide cycle that fluctuates. So while you're out there collecting that data, your frame of reference on the boat is going to change constantly. So to do that, we install these tidal gauges. As you can see on the left, that's Maggie Payne. She's a resource soil scientist with our agency. She's surveying in the bottom of a tidal gauge, and it's a pressure transducer which collects, water height data based on pressure, at the sensor. And on the right of the slide, you can see Debbie Sarabian and Maggie essentially running transects across the bay here, collecting bathymetry data. And when we're done with that data, we call it mowing the lawn. So you want to, space your transects, your traverses, tightly spaced so you're not missing any of the relevant topography. And you want complete coverage. It's very time consuming. You can get out and run transects, and it's weather dependent. You don't want to have, very rough seas or anything like that. And it requires, a fair amount of post-processing due to those tidal changes. And, we try and set up multiple tidal gauges and correlate between them depending on where you are out on that body of water. And in the end, you wind up with a decent base map. But we're tying it to the North American Vertical Datum of 1988 as a frame of reference, and that falls in between, typically your mean high and your mean low water, in that intertidal zone. But you have to have that frame of reference somewhere, so you're not unsure of what the water height or the water column is. This is an example of a bathymetry map showing the deeper areas in red, the shallow areas are in green, and you can see some of the channels there. Up in the northern part, of this survey area, there's a loading dock for basalt trap rock, and they've excavated a deep channel, dredged a channel so they could get some heavy barges in there. But this is basically your starting point of any survey is this base map. And one caveat here is when we're making base maps, we're not making navigational charts. So we leave that up to NOAA, the folks that know, that arena, and, these are for our purposes, and, we use them to carve out landforms and landscape units. After we have a base map, we try to go out and do some reconnaissance and some rough mapping, and we're typically using hand tools that we use on land, bucket augers, peat samplers, probes to get an idea where the highly fluid silty material is, where's the sandy coarse material. But if anybody's ever done this type of work, these hand tools have their limits, especially when you're in sandier material. I think the maximum depth we could get down was about 60 to 80 centimeters before, it just got too hard to work with these tools. You can go a little deeper if you're in the WASIS, the organic soils. Here's Jim Tureen here on the left. He's an assistant state soil scientist for Rhode Island with a 1 meter peat probe. He had that specially made by the University of Rhode Island, and that is a great tool for working in these highly organic soils. It sure beats the 50 centimeter version that many survey offices have. Just working in that subaqueous environment with the boat bobbing up and down, it's a lot easier to get cores in 1 meter increments as opposed to 50 centimeter increments. One of the tricks that he often uses is a rubber O-ring around the shaft of the auger to mark the water depth. So each time that you get that probe in there, he'll know exactly what the water depth is, and you can subtract that out and find your soil depth. So just different tricks that we've learned over the years. Coastal zone soil survey, is going to include not only the subaqueous mapping, but terrestrial updates as well. And we've done a fair amount of work in salt marshes across our area, as well as some of the coastal areas, and we plan to do a lot more. As you can see, areas that are mapped, as miscellaneous dune areas do have a lot of vegetation out there, and some of that vegetation is very critical for maintaining a buffer between storm surges and adjacent residential areas, especially as sea level rises. I'm going to go into a little bit about vibrocoring. This is how we get most of our, typifying pedons. Basically, vibrocoring is taking it's a concrete vibrator, basically has a motor attached to a heavy metal weight that vibrates. So we'll take that metal weight and we'll bolt it to a piece of aluminum irrigation pipe, and when you start the vibrator up, it liquefies the sediment or the soils, right next to where that pipe contacts, and you're able to push that well into the soils. And quite often, we're able to extract 2 meter cores with that process. And it takes some practice, especially there's certain techniques, like you have to fill the core up with water, cut some of it off, fill it with water, and put an airtight plug on the end, and typically suction will hold the sample in. And you can see that tripod on there, that's used to winch the core back up. Because there's a lot of suction force on the bottom, and sometimes it'll almost pull the bow of the boat down quite a ways before it finally lets go. So next we'll move on to cutting the cores. You can see that's like a pipe cutter's, a plumber's pipe cutting tool that's used to trim off the excess pipe. It's always a key as to where you are, and make sure that you want to cut it as close to that soil surface as possible. So you make measurements using lead weights and various methods, but usually it comes down to somebody tapping a metal wrench along that pipe until it sounds just right to give you the perfect cut per se. And usually these are capped on the boat and then transported back to shore, where they are split open at a later date. And you can see in that lower right hand slide, there's Sean McVeigh himself splitting open a core from Little Narragansett Bay. And it's always an exciting moment, when you cut those cores open, to see what you captured in all your efforts out there. all the description process is typically done back at the lab. These cores are transported into the lab, and most of the time they're kept in refrigeration to slow down the oxidation process. A lot of these have a fair amount of sulfides in them, sulfitic materials. So we want to typically describe them as fresh cut, and then what we will do is take and run those incubation pHs for sulfitic materials, but to keep that process at bay, we try to keep them refrigerated, and then we'll freeze half the core for archiving. And then that's where it's critical to have the use of a local lab like URI's lab. They have freezer space, they have refrigeration. It's not practical to be sending this stuff across the country. We're holding out a lot of hope for the topo bathy lidar. Excuse me. Excuse me. It is affected by turbidity in the water current. Losing my voice here. But there's huge potential for this to save us a lot of time and effort. If we can get access to good topo bathy, we should be able to do a lot of our pre-mapping, using remotely sensed data, and then it would save us a huge amount of time. I'd estimate between probably a third of your time is spent collecting bathymetry data. If we could eliminate that step, it would be a huge savings, and making this subaqueous effort much more efficient. So we'll be testing some of their data this field season. So I wanted to include a few slides on freshwater subaqueous work because that applies to a lot of areas, especially around the Great Lakes and whatnot. And you can see here it doesn't always require high-tech specialized equipment. You can get away with this homemade raft here, which URI put together for some shallow water work in Warden's Pond in Rhode Island. And the folks that work at the more northern areas, of the United States will find that, winter time is a valuable time to collect some data. We're doing vibrocoring out here on the ice, and actually it's preferred, I would say, to be out on the ice. You got a very stable platform, and this is a backpack vibrocore unit. And that thing just worked great. We use this ladder as basically a surrogate for that tripod, and we were able to winch it right up the cores, and we slid everything around on these rafts. It was a great way to collect a lot of data rapidly and get you out of the office in the dead of winter. The same with collecting some of the Freshwater there, the histic ones. You can get out there with that peat probe and get some good descriptions in the wintertime. Great use of the GPR unit, just running transects. You can see, even I can interpret this radar shot, with the water, organic, and the mineral substrate down below. Just you get some awesome data, very rapidly, with this technology. Just a slide on safety. It starts with proper planning. I can't stress that enough. Things happen out there, and they can happen very quickly, and it just pays for everyone to be well trained and well prepared for anything that could go wrong. And be safety. Safety is number one. It's not worth going after that final core if you got bad weather coming or what. You really got to play it safe out there, and it's important to be well trained and also know your water quality. You don't want to be down which are a priority for our agency. And, we don't want to just stop at the water's edge for these things. We're going to continue on. We're going to be developing ecological sites for our subaqueous soil components as well, to help tell the whole story of what's going on across the coastal zone. So that's my final slide. I'm going to turn it over to Debbie Sarabian.
All right. Well, my name is Debbie Sarabian. Again, I'm the state soil scientist for Connecticut and Rhode Island. Been working with our partners for many years now, and I would just like to stress that a lot of this work really started with our partners, the university, seeing that this work is important enough to research and that the information was needed. So all this data that we've collected has been with partners, and then moving into using the data was our next step. And so, we see and have gotten a lot of response for soil-based interpretations that could be developed for these areas, not just subaqueous, but near shore. So I'm just going to be touching upon a few of the experiments that University of Rhode Island, but other universities are doing. But I just wanted to highlight a few of them today. Some of them that we think are important is just looking at dredge material. And URI did this mesocosm study. On the right, you can see they put soil samples in these tubes, and they looked at different landscapes and measured the pH over time. So they found that these fine textured materials reach these acidic conditions less than 2 months, and they used the oxidized pH test to test for these acid sulfate soils. And so, this would be a potential interpretation that we'd like to produce and are currently working on, because if you've never seen an area that was used for dredge material that had acid sulfate soils, this is what it looks like. The pH drops very low, and it's hard to establish any kind of vegetation in these areas. So just looking at a potential map that we can make, this is Little Narragansett Bay and Connecticut and Rhode Island border. You can see here, we just did a rough map just looking at what sulfitic materials we presently have, and it looks like we have a lot of them there. So we definitely want to get these interpretations out to the public. Another interpretation we'd like to do is for oyster habitat. Could be for potential restoration efforts. So URI did a study looking at the growth of oysters in different landscapes or landforms. And obviously these landscapes and landforms are transferred into soil types. So they noticed that the grain size the coarser textured soils really influenced, and these oysters and the shellfish grew faster. So, I think it's a good indication that we can have a soil survey interpretation from this data. Sean, can you advance to the next slide? So the success of eelgrass restoration projects, in this slide you can see, it costs a lot of money to do eelgrass restoration, and all things being considered, they're looking at water quality. Your water quality is good. The next thing they're going to look at is sediment or soil type. And we were just at an EPA Zosteropalooza conference last week, put on by EPA out of Boston, and in September 2005, they put together a predictive seagrass habitat model, and two of the deciding factors or important factors that they thought were particle size or grain size and total organic carbon. So if we can provide that information as part of their model, and I think that this information is extremely valuable for eelgrass restoration. And you can see here in this table, the success rate is still not very good. Next slide. So some of the research done at URI looked at percent eelgrass cover depending on soil landscape units, and they noticed that high levels of the sulfides, high salinity, finer textures, higher nitrogen levels, they saw these higher eelgrass covers. So their model indicated that eelgrass could be explained by other properties such as sulfides, nitrogen, and organic carbon. So there's a lot of research out there that we can use to help build our interpretations and know what information and data we should be collecting. Next slide. So moorings is another interpretation that we develop with our data. So a lot of times the right mooring isn't put in to the right soil. So we looked at dead weight versus a mushroom. So the dead weight, you would want a more solid bottom, versus the mushroom, you want something more siltier and finer to actually grab that mooring. And if people don't know what a mooring is, it's just a permanent anchor. And a lot of times when there's a storm coming, you can't pull out every boat, and especially the insurance companies have seen in the devastation that it can cause, and they don't want to pay for these boats. So just knowing what type of mooring to put where is vital information. So Donald talked about blue carbon in the beginning, that a lot of people talk about blue carbon, they talk about tidal wetlands, mangroves, and seagrass meadows. And I pulled these up quickly just to show that there is a lot of carbon in these areas versus terrestrial forested areas. And in the upper left-hand corner, you see the soil organic carbon's the dark blue, and then the above living biomass is light blue. So it's got a lot of carbon storage in these areas. And then the carbon sequestration for these blue carbon habitats is large as well. So what about blue carbon inventories of subaqueous soils? Well, there's been research done on that as well. And you can see here on the table, the dark black soil classification groups are upland soils, and the blue highlighted soil classification groups are subaqueous groups. So if looking at the mean soil organic carbon, you can see that it's quite comparable to regional forested uplands, these mineral soils, versus our subaqueous soils. So this is something that we want to collect. We want our data to show. People are looking for. Other ideas and that could more research or data is needed in these areas for tidal marsh loss for this coastal subsidence. Donald talked a lot about that, what we're seeing in these cores. And then research into this thin layer deposition. If you haven't heard of that, some areas are thinking that And this thin layer is, you know, they don't really know what the thin layer thickness is. It can range from very thin, I think a couple centimeters, to thicker than we think thin is. But research is being done on that. They either want to spray these salt marshes to increase their height, or they're going to just lay out with big equipment some sandier material and hope that the marsh doesn't disappear. So some different techniques out there and research going on that we really want to be a part of and collect data and information on that. So that's the end of my presentation, and we'll take questions.
All right, and again, to remind people, you can enter a question in the Q&A, and we'll address those. So the first question, will the coastal zone soil survey help communities to prepare for climate change, sea level rise?
I would have to say most definitely. It'll provide them with a detailed resource inventory. One of the shortcomings of our existing soil survey is it does not recognize areas that are prone to coastal flooding. We've done a great job at capturing alluvial soils on the floodplain, but not necessarily coastal flood hazards out there, and that's a real place where we can make some improvements.
I would stress too that a lot of people are looking for information in this near shore area. I just talked to a steering committee the other day, and they felt that our information would be, you know, the information, the data that they're looking for to create this seamless information from it, that they're collecting in their deep areas, that they don't have the boats or the knowledge to collect.
There's a couple questions here related to petagenesis in subaqueous soils. So for the continental shelf being exposed in the past on the west coast and east coast, would that be the evidence of the petagenesis offshore, or is there petagenesis going on once the materials are in that subaqueous environment?
So we see both. In some of those profiles, we saw evidence of a terrestrial soil that was developed on land and then was inundated with seawater. So you have that, you know, that marine Holocene age marine deposit on top, which has its own properties, but you know, underneath. So there are both, you know, the current petagenic processes that are going on, and those past paleo environments that where you know, different processes were going on. So I would say, you know, you definitely have both evident, you know, depending on where you are on the landscape.
In the subaqueous soil description, do you generally provide a water depth above the soil surface?
Yes, we do, and quite often our map units are phased based on the water depth itself. Just like a slope may be a phase in a terrestrial soil or stoniness, we often phase them by water depth because, you know, certain uses, you know, for like aquaculture may depend on water depth dramatically, you know, change with that water depth. You know, it's a very important property. The water column in itself is one of the important soil forming factors of subaqueous soils. You know, whether that water column is very still or quiet and it has a certain depth, or is it very, you know, fast moving and subject to wave action and you know, exposure to air as well, you know, in the intertidal zone. So, you know, I'd say it's, you know, it's an important aspect that we always capture on our descriptions.
A question about salinity classifications. How are they determined for these soils? And is the surface water salinity data used, or is there a method for measuring the salinity within the soil profile?
I think it was, we had one of our coworkers here actually helped to develop a method. It's a 5-to-1 method of salinity determination. Marissa Tebb in our office, she worked on that as part of her graduate work here at the University of Connecticut, and I believe it's in the lab methods manual now. It's a column in NRCS where we do collect that data using that method.
And we actually call it halinity class, right? Not a salinity
That's
class?
correct, yes.
We wanted to call it halinity so it captured ocean-derived salts.
Another classification question. Are all subaqueous soils either anthosols or histosols? In other words, do subaqueous alphasols, ultisols, and spotosols also exist?
We have not described those yet. I think for now it's been just the wascyst and the wascent, but I wouldn't rule them out. I mean, as things, as this science develops and more pedons are described and taxonomy catches up to our observations in the future, I wouldn't rule it out.
There was a lot of work. There was a lot of work done by universities to, help make these changes in taxonomy, in NRCS. So there was a lot of work and research done by graduate students and university professors to help move this work along.
There's a question here in the chat. How and when can we access the coastal soil survey info?
Well, some of it is available right now. You can go for Rhode Island, you can go into Web Soil Survey and get that right now. Parts of Connecticut, we do have, parts of Connecticut done as well. So some of it's available, and then it's going to be, like Luis had stated earlier, it's going to be a long process. There's a lot of area to cover. We have a lot of coastline. So my vision is we're going to be doing segments at a time. It's not something that's going to be done, in a year or two at all. It's going to take some time.
You talked about mowing the lawn, and how long does it take to run bathymetry tracks, and how much does it cost?
Well, I think it took days, right, to do Little Narragansett Bay. How many days do you?
Pretty much it took us a whole summer to do Little Narragansett Bay, that one area that I showed you against Connecticut and Rhode Island. Because we have to put out the tidal gauges, we have to set everything up, takes time, and then you have to have good weather to be running that, and then there's a lot of post-processing. So that's pretty much was our summer, and when we had time, we'd start grabbing samples.
And it's slow. I mean, the boat, you can only go at a very slow pace, otherwise your data gets too scattered. So you have to really just putt along very slowly. So that takes a lot of time. And the expense, I think Dr. Mark Stoll had provided us with some numbers, right? Roughly around 60, it could be up to $60 an acre or something, all said and done for subaqueous mapping.
But that's a graduate student price.
Yep.
Hey, this is Luis. Let me just point out so folks know that we are already having some conversation with USGS arrows to see if they can share information, LiDAR. But I forgot what is the term that they use for the battery. But again, my point is that we are going to be working with folks out there like USGS, and we're also going to see if we can bring NOAA FEMA and other agencies out there that may have some basic information that we can use for this type of work. So if we are successful in that, with that approach, we're going to be able to save big dollar to the taxpayer. We're going to be able to save a lot of time to do some of this work.
Let's move along to some other questions. For the non-subaqueous soils in the coastal zone, is there available LIDAR data?
Yes, there is. It's pretty full coverage along our coastal areas, and I think that's what we're going to use when we do any terrestrial updating. The green laser LIDAR data at this time is incomplete and kind of spotty. In areas that we do have it, we're going to be testing that against our known bathymetry data to see what the correlations are. But so we see a lot of potential for using LIDAR to speed up the process, especially that green laser LIDAR for the subaqueous areas.
And I would say, too, a good example of updated coastal areas is Rhode Island. Jim Turin's done a lot of work there. Even the beaches, it's a bouldery or stony or sandy, and that's going to work great when we want to do interpretations with some of these, like the shoreline cleanup for oil spills. I mean, that's going to work great.
Has anybody digitized the marine navigation maps as a supplement for bathymetry, or is that scale too broad for pulling out the landforms? Yeah,
it's somewhat broad. We're doing 1 to 12,000 scale here. In Rhode Island, the minimum acre size in Rhode Island's a half acre. Connecticut's about an acre. So we found that we've really had to go out and just collect the bathymetry data. For Little Narragansett Bay, we did look at the NOAA 60s bathymetry data that was collected, and just to show that the area didn't change that much and that a soil survey could last a substantial amount of time, like our terrestrial surveys. We collected bathymetry in 2005, and between the 60s and the 2005 bathymetry data looked pretty similar, and that sold a lot of people on, hey, this data could be used for a while.
What kind of challenges did you have with access permission?
I would say mostly we haven't really run into a lot of challenges. It's mostly weather challenges. We've been very successful in getting slips or moorings in the area and having access, boat access. So it's just the weather time.
Yeah, for the most part, it's public land, so we're not, it's not like we have to get permission to run bathymetry or do coring or anything like that. So
I mean, we do have to get permission sometimes if we want to put a tidal gauge somewhere on someone's property. And most people, when you say you're doing research, they're more than happy to help you out.
Yeah, just working with the tides, that's a big issue. Timing your field work. Either a lot of times when you're doing the coring, you want a lower tide. There's much less water column that you have to go through. When you're running bathymetry, you want to have a higher tide so you can get in to the shallow areas and collect your data. So, a lot of it, is working with the tides and the weather.
1 to 3 meters of sea level rise is forecast by the end of this century. Will this inventory still be valid in areas once they become inundated, or when the subaqueous area is now 7 meters deep instead of 5 meters?
Most definitely. I mean, it's going to predict what is going to happen. As we collect this data, what we see now in these shallow water areas, you can project that up onto the landscape and see, exactly what's going to happen. What a predictive model this will be to have all this data, it shows what went on in history, and it'll predict what will go on in the future. I think it's key, that nobody else is doing this. Who better to interpret what it's going to look like in the future than soil scientists, that describe these cores. I don't see anybody else doing this work.
Do you analyze subaqueous soils for nutrients like nitrate?
We have not. I don't think we've tested for that. Have we, Debbie?
I don't believe so.
But that's not to say that, it probably should be done. Nitrogen is an important, element, in salt water that, creates like algal blooms and things like that. We should be probably testing for that.
Are subaqueous soils really records of paleoclimate and paleoecosystems?
Yes.
How is this project being funded?
Well, most of our state work has been funded through soils money given to the states. So Jim Jareen's worked on a lot of the coastal stuff and subaqueous soils, and along with the University of Rhode Island, who has either possibly received some funds from NRCS or other areas to get this work done. In Connecticut, these funds have gone through the state to the University of Rhode Island to assist us in collecting this data. So we're always looking for new partners and new funding sources that can that want to come on and assist collecting this data. We have the methods and standards, the quality control and quality assurance steps.
One last question. Is the National Wetland Condition Assessment an active part of the Coastal Soil Survey?
Well, I know that it's not, directly tied to it, but we do have some of our points within our survey area do fall within the coastal zone. There are, salt marsh areas that are, slated to be sampled at, as part of that project and that effort.
Well, thank you to Donald, Debbie, and Luis for your time and effort to make this presentation today. And thanks to all the participants for joining in. We had easily 100 people join today's webinar. The on-demand recording for this webinar will be available on our center's YouTube channel within a couple of business days. So feel free to let your colleagues know about this training opportunity. This concludes our webinar presentation.